Thank you. If you're gonna clap and I don't say anything, I can just leave now. If I'm that good. So, hello everyone. Thank you for being here. Thank you for Gig for hosting us. Only a bit over a year ago, I gave my first talk at the first PyMalta meetup, and we were 5 people in the room, and now we're nearly 50. So, yay, we're going places. So this is Introduction to Artistic Programming 1, implying that there's more than one. Using Python. That's where Python comes in. Let's get me out of the way. I'm Simon, software engineer, tried brain. That's it. So, art versus science. If anyone wants to open a can of worms, this is a can of worms we can spend all night on. You can look at it from many angles, like which is useful, is art even useful? Does science mean anything if there's no emotion in it? Blah, 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 blah. There's a lot of things you can raise. Let's raise our hands. How many of you are actually, would describe yourself as a programmer, developer, software engineer? Somehow you code. Okay. How many of you describe yourselves as artists? Okay. It's nearly unfortunate because that's not the same people all raise their hand, because there's no, if there is a bit of a barrier to entry to science or programming, if you will, because in science you either have a right answer or a wrong answer. If you write a program to calculate numbers, it's like 1 + 1 is 2. You can write a unit test for that. You're either right or you're wrong. In a business, your program either works or it has bugs, or in my case, it always has bugs. But there's only right or wrong. It's very utilitarian when it comes to programming, and especially commercial applications. However, the artistic approach lowers the barrier of entry. When it comes to art, there's no right or wrong. There's no, I don't know, Banksy is better than Van Gogh, or it's all subjective. So you don't need to go to university, you don't need to get a degree, you don't need to do a nano degree, you don't need to do online courses to become an artist, because making any simple piece of art makes you an artist. And this talk is just about bringing those two worlds together. I remember reading about how the MoMA, the Museum of Modern Art in New York, had acquired the source code to the original, the original Super Mario on the NES. And some pundits had thought that it wasn't art because it's a program, it's a game. And I remember reading criticism about this criticism, that calling one of the worst original and first and most widely played games not art because it's code is like saying that a Van Gogh painting is not art because it's oil paints and canvas. The medium does not make the final product. So in art, it's all about the means doesn't matter, it's the end that matters. So today I'm going to teach you, or at least introduce you, how to use Python, our most beloved programming language, to make art. I'm going to do that by making 10 works of art by the end of this talk. So strap in. Here we go. Work number, you're going to need processing. The processing framework is, if you ever used an Arduino, you'll recognize the IDE. That's because it's exactly the same one, because it's open source. Basically, it's a framework which offers primitives. In programming, we use integers, numbers, bytes, strings, and so on. Well, technically, it's all numbers at the end. We use those as our primitives, whereas in processing, our primitives are shapes and colors, circles, lines, squares, red, blue, green, and so on. It's available at processing.org. It's free, completely free. You can download it, and then you can also install Python mode, because originally it was written for Java, and then a very enterprising student in the summer of code decided to port it to Python. That means that we can hook into Python and just write it in Python, which makes the barrier of entry even lower. As we said, if you want to like start installing processing and so on and download it, feel free to do so. However, I'm going to keep going to the talk. Maybe by the time we get to the advanced examples, you'll have it installed and you can start trying it out. Well, let's start. Work of art number 1. I'm going to call this gray dullness. And it's meant to evoke a sense of nothing really matters. And it's going to be a gray square. Let's go. So the size function literally
Hello. So the size function is a bit. The size function. Huh? Hello. 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 Oh yeah. The size function literally defines how big your window is going to be. That's it. And if we run it, we're going to get our first work of art. Gray dullness. Applause. Yay, we're artists, everyone. Let's keep going. Okay. So, step number 2, work of art number 2, rabbit in a snowstorm. Has anyone seen Daredevil? Because that's where the, okay, let's see, one nodding head. Yes, that's where it's from. So, can you see the rabbit? No, because it's white. Hold on, I need to. So the background function defines the color of our background. And it accepts an integer or 3 integers, in this case 1. And if you give it one number between 0 and 255, it depends on, it decides, you're basically telling it how
bright, there we go. How bright the background is going to be. It's basically 0 is black, 255 is white, and everything in between is gray. Okay, let's run it. And there we go, rabbit in a snowstorm. Let's keep going. Work of art number 3, 333. It's because it involves triangles. Okay, it involves 3 triangles, each of which have 3 sides, just in case you did not know. And as I said, our primitives here are going to be shapes. So processing provides triangle, and then later on we'll see ellipse and rect as well for rectangle. And there's a number of modes you can run it in. So you can, for example, run it in a way where you define the, I think this was, yes, it's the X and Y coordinates of every single point. So this is X1, Y1, X2, Y2, and X3, Y3. You can run it in different modes, such as telling it how high the height and the width is, and so on, but I chose this. And if we run it, we get our third work of art, which insists on, there we go. Basically, if we change a number, okay, hold on. Oh, there we go. I think this point moved downwards. Okay. Work of art number 4, 4 sides, no points for guessing what this involves. Again, source code is extremely simple because processing provides a built-in function for declaring 4-sided shapes, which in this case is rect. The reason it's called rect and not square is because, well, a square is a subset of a rectangle. So all you'd have to state is X and Y coordinate of first the top left and then the bottom right corner. Okay. Ta-da. Thank you, thank you. Let me get to the more advanced stuff first. Wow, we're already halfway through. So, red car. For those of you who don't know me, I have a red car. And that's why I chose to draw my car using processing. And it's going to look like this. What's this? 3 is... Okay, apparently I missed one. So here we're going to introduce another function, which is the fill function. The fill function is literally telling processing to fill any shape that you're going to draw from now on with a specific color. It also accepts either one number or 3 numbers. If in this case I passed it 3 numbers because it's red, green, and blue, I use fill to declare the red color. I create the body of the car, and then I use fill again to add the wheels. In fact, here there's a good example of mixing a different number of parameters. So this makes it black, and then I use the ellipse function because circles are a subset of ellipses to create the wheels. This is just X coordinate and Y coordinate. I think it's top left corner. And then the width and the height of our cars. So if I want to give my car a puncture, which happens more often than I'd like to admit, we'd end up, I just have to reduce the height and there we go, I have a puncture in our car. Okay. Yes, so if I put it like 25, it'll look like an actual, there we go. That's, yes, accurate rendition of my actual car. Okay. Number 6, blue mouse. This is going to get a bit interesting. So far we've only dealt with static objects. However, you might have never heard of it, but you all experience it. There's something called persistence of vision. So when your eye receives some stimulus, the stimulus does not end immediately, but your eye takes a few milliseconds or nanoseconds to recover. And if you change the stimulus slowly enough, or rather fast enough, but in small enough amounts, that will appear as if something is smoothly moving. Even the fact that you're looking at me and you see my hand smoothly moving is because of persistence of vision. You might have heard the term 24 frames per second, and that is it's actually the limit at which most video cameras, at least older ones, used to film, and it's actually the frame rate at which nearly all films and videos are played back at. The reason we use 24 frames per second is because it is the absolute limit before which your eye can actually see jaggedy movement over smooth movement. Okay, and using processing, we can actually simulate persistence of vision. Where are we? Here we go. This looks a bit different compared to the previous stuff. Oh, there we go. So what I'm doing is setup runs once. By declaring the function, you're basically just overriding it and processing does the rest. So I don't want my window to appear once every frame, so I create it once using size. Draw runs once per frame. Your PC will try to run as fast as possible, but you can actually limit the frame rate by telling it frame rate 50, for example, and it will limit it at 50. In my case, background is being drawn every frame. So the whole window is being covered with a white background every frame. And then mouse moved is an event handler, which is called every time the mouse is moved. I'm calling fill to declare it's blue. And then I draw an ellipse using the center being mouse X and mouse Y, and 50 and 50. And we get the blue mouse as a result. And you think, why is it disappearing when I stop moving the mouse? Simply because draw keeps running. And the ellipse is only being drawn every time that I move the mouse. In fact, if I don't call background, instead, it's going to keep drawing circles. Just the thing is, since we're not removing the previous circle from the previous frame, they're going to stay there. Okay, so that's number 6. We're starting to get into motion and events. Next up, so Wheels on the Bus. Anyone remember this song? Those of you who have children definitely do. I don't think most of you. All right, so who's Maltese here? Okay, so the rest of you, do you remember when the old Maltese buses, not the blue ones? Okay, I see some nods. Those were the days. Some of them were yellow. The others were interesting. Okay. Now, we're going to start using a bit of programming expertise, if you will, knowledge. You can use functions. Since we're writing code, we can use all of the things that we already use in our day-to-day life, writing useful, if you will, code. So here I wrote a function to draw the bus. I don't do, because separation of concerns is a good thing. And don't repeat yourself is also a good thing. Now, because our bus doesn't fade in and out of existence if it stops moving, I'm drawing the bus each frame. So here's the bus. The bus has arrived. Yes. Here you can see it. This example, while it's a bit contrived, you can see how writing artistic programs does not mean that you don't write a good program. So all I'm doing here is that I've wrapped the code to draw the bus, where I create a yellow fill, I create the body, which is just a square, I create a black fill, and then I create the wheels. However, they're parametric now, because rather than hooking directly into mouse X and mouse Y, I'm using XY as parameters. I have bus X and bus Y, which are global variables. And whenever the mouse moves, I just update the bus X and bus Y. And in draw, I draw the bus depending on where bus X and bus Y is. So this allows you to start to deduplicate even your artistic code. Okay, moving on. This is called Loopy. Someone once told me that if two pieces of code look very similar, you can probably write a loop for it. And that's what we're going to explore now. I didn't write the code to draw each of these circles manually. I didn't copy paste it and just change the coordinates. Instead, I used our dear friend, the for loop. Loopy. Okay. That's always at the end. So in this case, processing provides a number of variables built in. One of them is width. This means that you don't need to store the width of your window in a variable, because processing will give it to you for free. I've defined how many circles I want per row. And then depending for I in range between 0 and the number of circles per row, I calculate the x coordinate of the circle and I draw it. This means that while this runs and creates 10 circles, I think it's 10, it might be 9, and I forgot. I can just as easily create 15. So why would you ever, you know, Chuchu van Gogh? Sorry, that's a Maltese saying. More is better. Maybe not always. Oops, there we go. I heard a certain interpretation from the front row. Let's keep going. So, work number 9, we're nearly there, penultimate work of art. Wow, I should have opened an art gallery at this point. So, moving loop. You're not going to see the movement part. However, now I'm just going to combine hooking into mouse moved with loops. So slowly but surely begin to bring all of the different pieces that programming languages offered, all of the different, what's the word? Strengths that programming can give us, and using it for art. Moving loop, here we go. There we go. So this is a combination of different techniques that I've shown so far. Mouse moves determines where center X and center Y are. And then each time I draw circles, and circles involves 2 loops, defining first the circles in the rows, in the row, and then the circles in the column. Pretty simple, 26 lines of code. And that's with the spacing, so if you reduce the comments and spacing, it's less. And it's also all parametric, so if I want more circles and smaller ones, that's just a global variable away. Okay, so moving circles, very inspiring names. This is the last work of art that we have tonight. Wondering why there's different screenshots? That's because the circle actually moves on its own. No longer does it have to rely on humans. The computers are starting to take over. They're becoming, you know, self-aware. And so is our art at this point. Yes, it's stuck in the corner. I guess I can change where it starts from, but let me explain the code. So setup is simple, draw is simple. I'm calling 2 functions. Draw circle is easy. It just grabs the same global variables we had in the beginning and draws a circle. Move circle is a bit more interesting. So I have a function which calls out of bounds, and it asks, is circle x, are these two, is x and y out of bounds? Out of bounds being, is the x coordinate less than 0 and is the y coordinate less than 0? Or is the x greater than the width or y greater than the height of the window? That means that our circle has gone out of bounds. And if it is, all I do is I switch the direction. Direction being where I increase the x position in the move amount times the direction. So it either moves that way or it moves this way. So its move amount, I think, is 20. Let's bring it down. Now it's a bit easier to see what's going on. All we're doing is every frame, are we out of bounds? If yes, change our direction. If no, do nothing. And then after that, grab the position, which is our center position, and either increase it times the direction, which will make it cause it to move forward and backwards. We could easily improve this by seeing whether the direction was, depending on which wall you hit, it reflects differently and so on. However, I thought that this was simple enough for today to show how we can exploit simple, extremely simple concepts of programming, which is just comparators and logic and functions, and yet produce something a bit more alive than maybe a backend API. You know, it's a bit easier to show something. If you show this to a child, they'll go crazy. If you show them a website, they'll be like, "Oh, what's new about this?" And I think that's okay. So we have some time left, and we sort of don't have time left. These are some challenges that I came up with to improve the last one. For example, add a second circle, bouncing from bottom left to top right. Make the circle change color depending on its x coordinate. I really like that one. And make the circle stop moving if you hover your mouse over it. Okay, I think I'll say my goodbyes and then I can work on the one to change color. So any questions? Thank you for listening. That was a light introduction to artistic programming. You can do a lot more. I wish I had my old source code downloaded because I'd show you. We had done like advanced simulations of swarms. I think I had showed one once. Sort of blue balls running around and self-forming. We'll get to that. That's not really introductory stuff. And the source code is on GitHub, so you can access it all from home. There. Talk one, implying there's more than one. Those are my details. And so if you want to get in contact, please feel free to do so. Thank you for listening. All right, so questions? Questions while I start live coding? Yes.
Hello, thank you, Simon, for the very interesting talk. I have three asks.
Thank you for yours as well.
I have three questions for you. The first, you started to ask us about if we think the program is more art or more science, and then I'm very interested in your opinion. What is you think this is more artistic or more science? What do you think? The second question is, in the last example, for me, is very, very interesting, but I would like to know, when do you show this, I thinking about the ping pong. Is possible to create a game in this library or no? And the last question, I would like to try this, and I don't see the GitHub. Is possible to open again for me to copy? Thank you.
Thank you. So, what was your first one? So, I think it was about whether this is more artistic or science. The proper question, at least for me, is rather than it's both. And for me, it's a shame that they are so much considered apart. I mean, think about it. For example, you'd hear, I think, purple dye in Roman times was used for kings and royalty because the dye came from some snail, I think, that was found underwater, and it was extremely dangerous to go get it. So because of its rarity, it gave the color status. In a way, you can look at a purple robe and say, "Ah, it's beautiful, it's artistic." But it was enabled by someone learning how to dive and get these snails. That diving might needed tools. So I don't see art and science as two different things. If anything, they should both complement each other and they should challenge each other as well. I know the possibilities for using software as art are extremely large, but most people just don't know about them. I heard recently about, for example, one of the fields, the more fancy fields about artistic programming is in augmented reality. And I heard apparently there's a floor again at the Museum of Modern Art in New York, where it's a whole floor featured, I can't remember, I think it's Jason Pollock paintings. And there was some group of artists who wanted to make a statement about vandalizing this art, however this priceless art. And even if you don't like the art, you're not going to go vandalize priceless art. And they created an augmented reality application where you can go in front of these paintings, and as you hold your phone, you see augmented vandalism of the painting on the phone. So it doesn't exist in reality, but they can still make an artistic statement through this science-based approach, which basically is code. So that's my thoughts. I mean, I can spend all night talking about this, so I'll stop here. Number 2 was, yes, and you asked about Pong. In the first year of my degree, I had to create Pong in processing, and I managed. And I managed it in Java. So creating it in Python was, yes, I had to use Java. So, you know, so if you can create it in Java using processing, you can create it in Python using processing. And number 3, introduction to artistic programming. Yes. Next, any questions? I've heard of it. So I haven't used Pygame. However, I did make a game in processing. I made Pong, so I know the pains. Processing is more of a. So let me start with the positive. Processing includes and abstracts away both 2D and 3D rendering. It also includes physics libraries and so on. So I have created like 3D visualizations, and I even had to create a 3D music visualizer once in it. And so you can do a lot of things with it. However, they also describe themselves more of a prototyping sketchbook rather than a fully fledged game engine or visualization engine, which should take you from start to finish. So that's what I look at it as. I look at it as a sketchbook. And like, let's say you want to start the painting, maybe you do your first sketch in the sketchbook, and then you put your sketchbook in front of you and you start your actual painting. I would use it for that. However, I know that processing does include some rudimentary export features. So I think there you can like export some basic applications for Android. You can export enclosed executables. So if you want to make something simple, or just, you know, maybe even something, it could be anything, given you can hook into anything. So you can even use, I think you can import requests, for example, and make art based on an API call, which you can also do in Pygame. However, Pygame, I think, is very much focused on games. Processing is a bit more wide, but then a bit shallower. So you can't go as deep with it, but you can do a lot of things with it. Next. Questions? No? So I'm going to start. You want to see live coding? So we said we're going to change the color depending on the x-axis. So setup runs once. So I can't change the color by running fill once. So first step is just moving fill, I had to put it here actually, into draw. Now, we want to change the color. Let's change at least one channel for now. Let's change the red channel. And it will change depending on the x-axis. So at first, we can just as easily make sure that circle X is here. Because circle X changes as it moves through. Now it's not changing. Why? I probably, okay, so let's see. It should change towards the top left. Exactly. Thank you. It's not changing or beyond 255 because the maximum number for a channel is 255. So what do we need to do? You can divide it, but there's also a built-in function that can do it all for you. So let's call it blue. And we can use map. Map takes 5 parameters. It takes the variable you want to map. It takes the range it is currently in. So if it's the x-axis, then it's 0 to width. And it takes the range you want to put it in, which in our case would be 0 to 255. So this is all from memory, so I might be wrong. This is complaining because it's a built-in. Let's call it red call. Sorry, coding with one hand and holding a microphone and speaking is a bit more difficult than I remember. And now, no, something's wrong. Yeah, it's changing. Yeah, it's slow, but that's because it's depending on the x-axis. Okay, there we go. No, it's working. And to make it a bit easier, let's just take a look. Ta-da! Now, last thing, how about we change? The beautiful thing about processing is that usually in programs we talk a lot about scope. Scope being where this variable exists and make sure we don't leak it and so on. And usually we think about our interface as a single thing. The person interacts maybe with a web page, the web page contacts the API returns, the web page reacts, and then the user. However, in processing, I like to mix a lot of scope because it leads to interesting things. So we can also, for example, change the green color, green, depending on the position of the mouse. Doesn't have to be the position of the circle. So let's say that we're going to map mouse Y between 0 and height to 0 to 55. Ooh. There we go. And you can go and show this to someone, or even, for example, I had used processing recently to generate, actually I'll load it up in the meantime, to create some generative art. And you can print it and the person might see it and be like, wow, that's awesome. How did you paint it? And all you have to like just print out the source code and show them. I think that would be very surprising to most people. Let's try something like, let's try this. It's not exactly as easy as before. So this is a combination of genetic algorithms along with art. And so here is just a visualization of a genome being a set of characters. And I have some, the genes have 3 points which create triangles and also colors. And I have some controls where I can modify, add or remove genes. So each time I press A, it's adding more and more triangles. If I hold down M, it's slowly editing the points of the triangles. If I hit R, we're removing triangles. And basically you can just keep going and generate some pretty funky stuff if you're into this kind of art. Save this file and print it. And the nice thing about this is that it's deterministic, meaning that if you print the string, the genome, you can recreate it. I also have another thing here. If I can find it, I think it will be this. So in this, I was also generating triangles. However, given that we're using programming languages, we can use I/O as well, as Joe told us. So in this case, I'm generating the same thing as you saw, random triangles, random positions, random colors. However, then I'm saving each one to an image. So in fact, processing offers all of this built in. You can call save frame, which will just grab whatever in the box and save it to a file. And then I'm buffering them and I'm blending them together. So we're also introducing a bit of image processing here. And in fact, since you also have a console at the bottom, so you can see it's saving files. And voila. Thanks to the blend. So that is just, and again, I can show you. So these are the files that it generates. And then using overlay image processing, you can overlay different colors and produce certain effects. And in fact, because of the interaction of the colors, you begin to get that stained glassy, watercolory effect, which you might think you can't do with programming, but you can. That's all I have tonight. Thank you for listening. Say goodbye.